Hello everyone, I hope all of you are doing great. I'm Shakil. So in this video I'll try to explain the non-linear regression analysis by using Stata. So let's move forward. So before we talk about non-linear regression, so we need to know what is the difference between the linear regression and the non-linear regression model. So if we consider example of whether a person's experience have any impact on his salary, so obviously there's a concern that if the person have more experience, that it can impact on his or her salary. However, so economists some believe that it's not always true that experience will have a positive impact on salary. However, after a certain period, for example, if the person serve in a company for more than 10 years or 20 years, so after 20 years there could be a decline in his salary. So this is actually the non-linear impact. So in the linear impact, in the graph we can see, with the increase in experience there is an increase in salary. So this thing can explain by this model. So experience have impact on salary. Now if we move forward here, this is actually the non-linear relationship. Here you can see, there's a certain increase in experience and there's a certain increase in salary. So after that particular point there is a significant drop in the level of salary. So this one actually we call the non-linear relationship. So it's also called the inverted U-shaped relationship. So here you can have U-shaped relationship and inverted U-shaped relationships. So now, so what could be the U-shaped relationships? So if we consider an example of CSR, for example, for CSR we can see that there is a impact on company profitability. So if the company do more CSR, then the profitability can be increased. Now there's a point. So when the company start doing CSR, so it incur additional cost, am I right? So in the beginning years, obviously due to CSR there could be a negative impact on the profitability, but after a certain level, there could be a positive impact. So that's, you can say there's a U-shaped relationship between CSR and company financial performance or profitability. Now if you consider the example of experience and salary, so obviously if you have certain experience, then your salary will gonna increase, but after certain point your salary will gonna decline. So now we call this is as a critical point. So you need to find the critical point. So to find the critical point or critical value, so this is actually the formula I'm gonna explain later. So it's like alpha 2 divided by 2 into alpha 3. So alpha 2 is actually the coefficient of the independent variable or coefficient of the experience, and alpha 3 is actually the coefficient of the non-linear value. That means this alpha 2. So this is actually the alpha 2 and this is alpha 1. So actually in this equation you can just adjust, so we can just tell it this is alpha 1 and this is alpha 2. So we'll get the coefficient of alpha 1 and divide with the coefficient of alpha 2. So that's it. So let's move forward. So we'll show you a example of real data. So here I have some data actually. So if you just go to the Excel file, so I have already I have some data collected before. So let's move forward. So in my study I want to see whether board gender diversity, that means the male female ratio in a company board, have any impact on environmental innovation. That means if the board has more diversity, then whether it will impact the environmental innovation in a positive way or in a negative way. So that's what I want to see. Now as you can see, board gender diversity is a number. So obviously due to increase or decrease in number, there could be a non-linear impact. So I want to capture the non-linear impact of this study. So for that obviously we have two models. So in the linear model, so left hand side we have the dependent variable environmental innovation, and right hand side we have the independent variable, that means board gender diversity. And I have included a few control variable based on the company. So first one is the leverage, second one is the liquidity, and third one is total asset. This is taken as a proxy of firm size, and then we control for the firm profitability as well. So the non-linear model is this one. So if you see, there's only a basic difference. So that means we squared the, like, independent variable or board gender diversity. So actually we have here two variable, one is board gender diversity and then the square of the board gender diversity. So basic difference between these two model, you need to square the independent variable, that's it. Now, so when so there is a, like, issue. So how could you know that, whether there is a non-linearity or not? So to get the impact of non-linearity, both of these variables should be significant. That means both gender diversity should significantly impact of environmental innovation, and the square term of both gender diversity should also influence environmental innovation. Only then you have a non-linear relationship. So that's it. Let's move forward. Let's go to Stata. So now I'll just go to Stata. So I'm using Stata 18. So what you need to do at first, you need to click on the file and then import the data set you have. So I'll go to import Excel spreadsheet because my data is Excel data. Then I'll browse it and I'll select this file. So I click on that. So it will take some time to upload the data. So the data is already uploaded, we can see. So here you can see the number of rows, row 1, row 2, and row 3. So but my first row is actually the variable name, so ID, year, and other stuff. So if you don't click on this dialog bar, import first row as variable's name, then it will not gonna consider this as a variable, it will consider as a data. So you can see when I uncheck it, so this is considered as data. Now when I click it, then the number 1 removed, and then this one is considered as a variable name, and then this is considered as data. Everything is done. We need to click OK. Now we can see your data is uploaded. So here you can see the variables. So if you want to double check whether the data is there or not, you can just click on the data editor. So I just click on the data editor, and then I can see all the data are here. Now let's move forward. Now this data set is actually consists of multiple countries and multiple companies. So I have like nearly 2,300 companies, European companies, with the data from 2016 to 2022. So this is actually a panel data. Now I need to tell Stata that this is a panel data. To announce that whether your data is panel or not, you need to type a code. The code is xt set, and ID means the company ID, and then time is year. So when I click on that, so you can see this is panel variable and strongly balanced, and the year is from 2016 to 2022. Now this one is done. Now the next thing is you need to do a few things. So in your data there could be some extreme values, so we need to so it's also called outliers. So some people, they drop the outliers, but there's another way to trim the outliers. You don't need to drop the outliers, but you can trim it. So we will trim it at 1 and 99% intervals. So for that there is a code actually, so we need to use it. So I have the code already here. So the code called Windsor, or we could do it Windsorize. So Windsorize is actually trimming the extreme values. So we'll Windsorize the thing. So for that, what I need to do, just copy the code. So I copied the code. So the code is Windsor 2, and then after that we have our dependent variable environmental innovation, and then we have our independent variable both gender diversity, and after that we have our control variables leverage, liquidity, log of total asset, ROA, and after that you need to put a comma and then type suffix underscore w and level. So that means obviously this variable we're gonna rename with slash w in it. So if you just do it, then you can see there's a new set of variable already created in your list. So both gender diversity, environment, innovation, leverage. So if you go to the data editor, so you can see so you have like new set of variables here or new set of data after Windsorize. So they don't replace the original one, so they create a new variable after Windsorizing at 1% and 99% interval. So Windsorize is done. So the next thing is whether you have a multi-collinearity issue between your continuous variables. So we need to check whether there is multi-collinearity, and then we also need to check whether there is any heterogeneity between between the yield term and other stuff. So you need to check the hetero issue and then multi-collinearity. So for that, actually you need to run a regression first. This is called quireg. So you need to use the quireg command. So what you can do, just copy the code from here, or you can type it. So it's easy to copy, so I copy the code and then paste it here. So the code is like quireg, reg or regression, and qui means quietly, and this is our dependent variable environment innovation, and then you have your independent variable both gender diversity. After that I have a 4 control variable. So I took the Windsorize variable, you can see slash w is there. So I run it. So when you run it, then you can check for the multi-collinearity first. So to check whether there is multi-collinearity issue between the variables, we call it variance inflation factor. So this is pretty simple. You just type VIF. So if you type VIF, then you'll get the VIF results. So there is a benchmark for VIF. Some people take it as a 5 or some people take it as a 10. So you can see all the values are below 5 or below 10. So we don't have any multi-collinearity issue between the variables. So when the multi-collinearity issue is done, then you can check for whether there is a hetero problem. So that means we have a error term, am I right? So whether your error term is homogeneous or heterogeneous, we need to check. So normally we expect that our error term will be homogeneous. We don't want our error time to be heterogeneous. So to check for hetero problem, we just run these two code. So enter. So first one is Bruchpagan test, and the second one is the white test. So both tests serve the same purpose, but we just run it for the robustness check. So first one, you can see is a significant 0.008. that means this one is significant. So we have a significant hetero problem, and if you just consider this p value as a 7 point e, so this is a scientific value, so this is like lower than 0.000 something. So both of the tests show that there is a significant hetero problem. So we need to address this hetero issue when we run our main regression. So I'll tell you what you need to do. So these two things is done. Next thing is actually you need to have some information people. So what we do, we see the summary statistics, so summary of our variables, and also we see whether there is any issue of multi-collinearity as well by using Pearson correlation. So I'll just run these two tests as well. So if you go, so okay, at first I'll run the summary statistics. So summary statistics, actually we want to get the summary of our variables. So what is the mean value, what is the standard deviation and minimum and maximum, and what is the number of observation, we'll see with the summary statistics. So you can see the summary statistics is so environmentals, we have more than 7,000 observation and mean value is 33, and then both gender diversity, you have like more than 7,000 observation and mean value is 28. So that means the mean average of both gender is 28%, or like nearly 29%. So that's how you can do it. And then after that you can run the pairwise correlation in Stata. So for that, the code is very simple. The code is pwcor. This is like pairwise correlation code. So just copy the code to save time, and then just come here, enter. So you can see the pairwise correlation result here. So here we can see, so the benchmark is 90% or less than 0.90. So all the values are like less than 0.9, you can see here. So we don't have any collinearity issue here as well. We already checked with VI, but this is another way to check whether there is a multicollinearity issue or not. Now let's move forward. So we need to run the main regression result, and we need to see whether there is any collinearity issue. So at first, what we're gonna do, we're gonna run the regression, normal regression. So x2reg is the code for the panel data, and then we have our dependent variable environment innovation, and board generated diversity is our independent variable, and then we have 4 control variables. After that, we put a comma. Now I used a function called robust. So why I use robust? So the reason to use robust, because we're gonna use the robust standard error. So when you check for the hetero problem in your standard error, you find significant hetero problem, am I right? So here it was significant, this one is also significant. So I told you that if your error term is heterogeneous, then it's the issue. So to resolve the issue, you need to use robust standard error. So therefore that reason we use the robust function. So when you use the robust function, then you'll get the robust standard error. So now it runs. So run the regression. So when you run the regression, oh, I forgot to put fixed effect. So I want to run the fixed effect regression. So I put fixed effect FE. So this is the result. So here you can see the board generated diversity. So this is the coefficient, and this is the statistics, and this is the p-value. So your p-value is like 0.001, which is less than 0.1%. So that means your result is significant at 1% significance level. So that means what? If the board generated diversity increased by 1%, then your environment innovation are going to increase by 0.1379. So the result is quite significant. So this is actually the linear regression. Now if you want to run the non-linear regression, so for that you need to have a squared value of this board generated diversity. So if you come here, so we just run this linear model, so board generated diversity and environmental innovation, and from the linear model we find that board generated diversity have a significant positive influence on environmental innovation. Now I need to run the non-linear one. So for that you need to square the board generated diversity variable. So you just need to come to Stata, and then I have the code here. So you need to generate a new variable. So you come here, paste it. So I just type generate. So I just type the variable name board generated diversity W, and I just put 2. That means this the square one equal to board generated diversity, and then I just run. So you can see there is a new variable board generated diversity squared. Okay, so this is our new variable. So we need to incorporate this variable in our model. So this was our linear model, so we just need to add this variable here to get our non-linear result. So just click on this variable. So here you can see x2reg is the common for the panel regression, and then this is environmental innovation, this is board generated diversity, and these are the 4 control variable, and we use the fixed effect regression and robust function. So you just click here, and then you add this variable. So we have just added this new variable in the linear model, and then run it. So when you run it, then you'll get your non-linear regression result. So first one is the only the board generated diversity. You can see there's a significant positive influence of board generated diversity, and then you can see the board generated diversity, the squared one. So you can see there's a significant impact, but it's a negative impact. So you find a positive impact here in the normal one, and then squared one you find a negative impact. So how to interpret whether there is a non-linear relationship or not? So when you have, like, significant impact on both of these, that means you have a non-linear relationship between both gender diversity and environmental innovation. However, if this one is insignificant, that means you don't have any non-linear impact on both gender diversity and environmental innovation. Now, in the beginning, I told you about U-shaped relationship and then inverted U-shaped relationship. So this one is actually inverted U-shaped relationship. Why? Because at a certain point it increased and after that it decreased. Now you need to find the critical value for this. So how to find the critical value for this? So if you just go to the slide here, so here is the formula, am I right? So you need to find the critical value. So how to find it? So alpha 1 divided by 2 into alpha 2 minus. So what is your alpha 1 here? So alpha 1 is this coefficient, so 0.322. so this one is alpha 1, and then this one is alpha 2. So you need to multiply 2 with alpha 2. So if you come here, so you can just put the value. So if you put the this value and divide with 2, multiply with these values, and then you'll get the critical value. So the critical value will be 47%, I guess. So for example, obviously there is a increase. So if you have both gender diversity, so there is a positive influence of environmental innovation. So after what point there will be negative influence? So the critical point is after 47%, there will be a decrease in the value. So both gender diversity square term will have a negative impact on environmental innovation. So that's how you do it. So this is actually the initial idea how to run a non-linear relationship or non-linear regression in Stata. Now, so there's a easy way in Stata how to get the results in a Word file. So I want to get the result in a Word file. So for that, what I need to do, I just type a code as doc and robust and then nest. So if I write these two code, then I will get the result in a publication style table. So I just put replace. Oh, sorry, I put a comma here. Okay, done. So this is my so you can see my file doc. So if you click on that, you'll see a new Word file will gonna appear. So here is the regression result. I guess just make it bigger a bit. So where is the regression result? You can see with the publication. So here both gender diversity have a positive influence on environmental innovation. So you can see that it's like 3 star means it's a 1% significance level, so it's strongly significant. Now if you just look at this non-linear impact, so you have a negative impact obviously. So the star is 1, that means it's in 10% significance level, so we have a significant impact. So non-linear impact is there. And as I already told you, if you want to get the critical value, then what you need to do, you need to divide this alpha 1 value, that means coefficient of both gender diversity, and divide with 2, multiply with 0.003. So if you do that, then you will get the critical value. So this will be your critical value, after which there will be a decline in environmental innovation. So there will be negative impact. So that's it. So if you want, then you can also get this summary statistics as well in Word file. So you just need to type as doc, and then that's it. So if you run, then you will get the summary statistics as well. Sorry, I need to close it. So here you can see the descriptive statistics as well. And then if you want this pairwise correlation, also do the same thing, type as doc. Okay. Okay, so here is the pairwise correlation value. So I just type asterisk. So this is at 1% significance level, so you can see the star. So if you want, you can just get the result at 5% significance level as well. So you just need to put 5 here, then you'll get it at 5% significance level. Now you can see the 5% significance level. So if you want to get it at the 10% significance level, then you can just type 10 here. So you'll get the result at 10% significance level. So here is three table at 1%, 5%, and 10% significance level. So that's it. So thanks for